This is the second day of a 2-day lesson on solving absolute value equations and inequalities. So this is the warm-up for the second day where I review what we did the previous day with using the concept of absolute values of distance from 0. So in the first one, we can look at 6 units from -1 each way, or we can set up the two equations and say that we know that the expression inside should be equal to either 6 or -6. So if I took -1 and added 6, if I knew it was 6 units from -1, that's going to be equal to 5, and that shows up in the first equation that we solve. Or if I took -1 minus 6, that's going to be -7, and that's the second solution that we get in the second equation. And we can show those with closed dots just at those 2 points on the number line if we wanted to, or just a solution set. This is x plus 1, absolute value of x plus 1 is greater than or equal to 6. So we can still use those same two boundary points. We know that this does have an equal sign in it, so it still will be closed circles at 5 and -7. But we know when we take the absolute value, if we want those numbers to be greater than those numbers, it's going to be outside to the left and to the right of those numbers. And so we could also do interval notation with this. It would be open bracket at -infinity all the way up to 7, close bracket, and then union to show or, and that's going to be a union sign, a union, and then it's going to be a closed bracket at 5, and then to infinity open bracket. And then we have absolute value of x plus 1 is less than 6, so 6 units from -1. Again, those same boundary points, -7 and 5, we can use, but this time it doesn't have an equal sign. So I know that at -7 and 5, that's going to be open circles, and this time I want everything to be less than that, so it's going to be all the numbers in between those two numbers. And for interval notation for this, it would just be open bracket at -7, parentheses, comma, and then to 5, and then open bracket again because no closed circles. We also reviewed the exit slip from the previous day, and one career that I relate a lot to when talking about absolute value with students is quality control, or people that look at specifications that manufacturers should be within for products. And so the first one we look at, that a box has to be 0.1 inches within 5 feet. And so we had, so we could have 5 plus 0.1 or 5 minus 0.1. That would be our boundary points. So that would be between only 5.1 if you added 0.1, closed circle because of the equal sign and the inequality, and then closed circle at 4.9, or anything in between there. There's going to be those solutions only that manufacturer can do for the box. And then we look at the second one, which is an actual weight, would be represented with X, actual measurement for a car part, and ideal would be 12 millimeters, I think it was in. And so it should be 0.125 within 12 millimeters. And so we have, it has to be out. We're going to look at the ones that have to be recycled. So those are going to be greater than 0.125 that we throw out and have to recycle and we can't use. So we're going to look at 0.125 from 12 would be 12 plus 0.125 is going to be 12.125. Oops. And the other one, if you had 12 minus 0.125, that's going to be 11.875. So anything outside of that, so it's going to be open circle because there is no equal sign on those boundary points. And then anything outside of that, we're going to have to recycle and for car parts.